Hello everyone, it's July the 9th. Oh, first things first, I solved this problem last night. I just feel a little frustrated, I just couldn't solve it, like what the hell? And then I started searching online to see if there's a way to run all the promises in parallel. And then I stumbled upon this method, promise.raise. There's promise.all, promise.any, which functions very similar to array.every and array.every and array.sum, right? Array.every and array.sum, promise.all and promise.any, which promise.all is it will resolve. It returns a promise as well, but it will resolve when all the promises in the array gets resolved. Promise.any is any promise that gets resolved. Well, any promise that does not reject any of them, that does not reject, if the first sum that got resolved, it will come out, but the rejection does not count. And also promise.raise, which is anyone, rejection or come out, whatever, whichever one finished first will come out. So by using this promise.raise, I call this function, right? This one will return whatever it needs to return, right? And also call this function. And I just realized I can just resolve it to true. Not really. So what I'm doing is I will resolve this first one after time t, right? And once it's resolved, I'll set this flag to true. So on the outside, it's false. So when this one gets done, either because this promise got resolved and this has not, that we have expired equal to true, then it just has expired, right? If it expired, we show it rejected. Or if this one gets resolved first, then this remains false, then I can return the result. Or it doesn't matter if this resolved to a rejection, then it will reject right here. So whatever it is, and also when you do raise, whichever that does not get resolved or rejected gets canceled. So it's like, wow, that's perfectly what we need. So I just tried it and then it worked. I don't know, maybe the intended solution just based on this thing doesn't seem to be I don't know, if they're probably trying something else. Like I just don't want to think about it. So I'll read about it later today for sure, but for me it's using race. Is it like a cheating? No, it's not. But I do have to look online documentation to find that. Anyway, combination sum. Let's do this. Given an array of distinct integers and a target integer, return the number of possible combinations that add up to the target. Number of possible combination that adds up to the target. So all the value you can reuse them. So basically I say if I take 1, 1, and then I run how many different ways I can do. I'll take 2 1s. Not really, we just take 1, right? We take 1, so it's 1, 2, 3, give me 3. And I take another one, so it's 1, 2, 3, give me 2. Take another one, 1, 2, 3, give me, so yeah, so we do that. And at the end we take 1, so we got 4, right? That's 1, 2, 3, and you get a 1. Then you can also choose to say I don't take 1, right? So for each nums, you have an index, and you have the current target, and you want to find from the index to the end how many different ways can you form this target. So you can take the first one, so it's index, right? So you can take the index, so I have to go to the index again. Or you can say, I don't want to take the index, I just want to take the second one, which is perfectly fine. So you do that, right? So it's gonna be a DP, right? So it's very classic DP. You have a DP, you get an index, and you get a target, right? And what's the edge case? Well, the edge case is I mean you can sort. Actually, I think I'm gonna sort nums. Yeah, negative numbers will make this one slightly different. We'll deal with this later. So I need to sort the numbers so I can terminate faster. So I sort nums. Okay, so nums sorted go up. So whenever I say nums index, right, if it's larger than a target, then boom, that is return 0, nothing, right? And of course, if index is equal to the length, that's also return 0. Okay. Other than that, we check if this is init, index, target. And target is to 1000, which is fine. So I need to do 1001, target plus 1. Okay, let's give this a shot. Well, to start with, we need to... Yeah, I was testing something today. Oh, I forgot. How do you sort? I think that's enough. Int memo. All right. Then we say int nums. Right. So this dot nums equal to nums, and memo equal to new int. How many rows? So I will go index first. So that's gonna be nums dot length, and column is gonna be value. So target plus 1, because I need to include target as well, right? And then I'll call a DP function. So we say int DP, int index, int target. If index is equal to nums dot length, depends. If return 1, right? If no, target is equal to 0. If it's 0, then otherwise it's 0, right? So that's one scenario. Another scenario, if nums index is already larger than target, then we cannot do any more, so it returns 0. Otherwise, if, oh, I remember, integer. It's very important. If memo index target is equal to null, that's what we need to do. Now we set memo index target, we set it to 0. All right, and then what? Then we're gonna say start from the current one. We can choose to take, right? So option 1, take nums index, right? Oh, and now also there's one more scenario. If it's this, if actually that's it. That's it. That is the scenario. Like if target become too small, right? We will take it. then we shall say memo index target. Actually, I don't even need to do this part, right? Yeah, I don't think you need. So this will equal to dp index. Don't change because I'm taking it, but target minus nums index, right? So because I'm taking this and then the remaining, so however many methods they have, will give it to me. So then we have option 2, do not take nums index. Now if I don't take num index, then index target will plus equal to dp. Then, so I'm not taking this, right? If I'm not taking index, which means I don't take this one at all, right? I don't take this one at all at the current time. So we're gonna do index plus 1. So next time we'll move on to the next one. And then it will do the same target. So blah, blah, blah. Once we're done, we'll return memo index target. So now we can say we'll return dp. We start from 0 with target. Okay, let's give this a little try. Something's not right. All right, debug this. Yeah, that procedure is very straightforward, and you know what to do. Just know it doesn't work. Debug 1, 2, 3, and int target 4. Combination nums and target. All right, it doesn't work. Nope. Okay, that's fine. Short it. We're going from 0 to target, okay? And then initially is 0. So shall you go to minus this, or not including 1. Okay, if I don't include 1, then we have 2, 3, right? Then we'll take 2, that will be 0. If I don't take 2, we'll have 3. Then we go to the end. So that's also 0. So yeah, so I have to include 1. Now we have 3. Oh, that 1, 1, 2, 1, 2, 1, and 2, 1, 1 is 3 different. Huh. Oopsie doozy. Oh, we're gonna have some issues. Because the first position. Ooh. Damn. I'll deal with that later. I'll take 1. So that shall equal to. That's 3. Right? So I can take 2. But if I take 2, but still, at least I shall get 1, 1, 1, 1, right? So So 1, 1, 1, and eventually, oh, I see. This condition is not right. Sorry, condition is wrong. If target is equal to 0, that just return 1. If this at the end, I'll say or num's index is larger than target, that's return 0. Okay, this probably give us 3 or 4. Yeah, we have 1, 2, 3, 4. 4 uniques. Okay, 4 uniques. But that's not what they want. Okay, so we have 4 uniques. So the question should be, if someone take that as the start, what is it going to be? So we have 1 at the start. Right? Basically, these are 1 at the start. We have 4. 1. Oh, these are 1 at the start. They only go 2 at the start. Ooh. Dodgy. 2 at the start. Then we go 3 at the start. Well, 1 at the start. If we go 2 at a start, then every time, if I say 1 at the start, next we start with 1. If I don't take 1, yeah. If I don't take 1, if I don't take 1, it's actually just 2 and 2, right? What if I say I take 2, but I also allow 1? How's that gonna work? So we can think about the DP as given the current index can be the leading. What is the total, right? So if 1 is the leading, what is the total? And then plus 2 is the leading, what's the total? 3 is the leading, what is the total? Right? 3 is the leading. Who is the leading? Okay, so that's slightly different, right? It's a slightly different. So this should still be right. And if it gets out, or this is the leading, index is the leading, and if this is larger, then that's not going to be good. Otherwise, we can say we want this to be the leading, right? Current index to be the leading, and who is the leading? So each time I say this is the leading one, but for the remaining I can pick whichever. We can take whichever gets, no, hold on. If this is the lead, well, what do you mean by leading? Since I'm taking this out, right? So once I take this out, for the rest, so I think this needs to change. Hold on. So memo index target should be equal to 0, right? So this is just saying I'm lead with index, okay? I lead with index and target. And then we're gonna go through each one, right? We're gonna go through each one to see which is the next leading, right? Which is the next leading. So I can say for int I equal to 0, I smaller than nums.length, I plus plus, right? So when I want to find the next leading, so we say memo index target into plus equal to dp. Next leading is going to be I, doesn't really matter which one, so target minus nums index, right? Which is just saying with the current target, the current index, that will be the one we'll put it first, right? And then for the next one, who gonna lead? We don't know. Any one of them can lead, right? So we throw all of them. And then that's it. That's how we find all of them here, right? Now, this, I'm gonna say res equal to this, right? And then for int I equal to 0, I smaller than nums.length, I plus plus, res plus equal to dp. I say I'll lead with I, give me target, or lead with the next one, give me target, lead with the next one, give me target. Once I'm done, I'll return res. Does this one work? This one give me 21. It's a bit too much. So you're duplicating some stuff. Yeah, it's 1, right? As I'll lead with 1. Okay, need to what if I just say memo, not memo, dp, lead with 0 and give me target. Does this give me 4? Let's give me 12. This gave me 12. I lead with 0, right? And then I basically say I take 0 off, right? I take 0 off, so I have 3. So the next one I say I'll lead with 1, or I'll lead with 2, or lead with 3. So if I lead with 3, so index is going to be 3. And then 3, 3, right? Memo is going to be 3. Now 3, 3, 2, 0, 1, 2. That's the second position. So 2, 3. And then we go from 0 to the end. And each one we try to add. So that will be 0, right? And then we go to the first one. So you're duplicating. You are duplicating. Then don't do this, okay? Whenever index is the one leading. So maybe we can just say if target is equal to nums index. So let's do this first, then do this. This is 4. This give me 4, which means we try this. It's giving 2. Oh, this seemed to be right. for int I equal to 0. Why did you delete that? You know it's going to be correct. You should just comment out dp I and then target, and now I return res. Boom, 7. Oh, this actually require a little bit consideration. In that case, sorting is not useful. You don't need to sort. But we did still sort because we can do this. Yeah, I think sorting is still useful because you can have an early exit. Early exit. Yeah, I think you can do a early exit. Otherwise, if you had something big, you have to keep going. Okay, try these two. We have 2 of these here. All right. Now on test, just go ahead, show me. Yep. Oh my goodness, 15 milliseconds with 5%. That was bad. Seriously, that bad? Huh. Really? That bad, huh? I had a higher hope for this. 15 is just bad. The number of combinations to make up target with num's index as the first value. I expect this to run OMN. Well, I mean, this would be target. Let's say NT. But you have also this. You have ON squared, where N is length of nums and T equal to target. Maybe that's why it's slow. I have ON squared, so can we not do this? This basically say if I take the first one, right? I take the current one, and I want to know what is. Yeah, can we do better than this? Well, I mean, I guess another way we can try is use the previous method, okay? Then we record what we have at the end. Then we find out how many uniques they have, and then we can compute all the permutations. So depending on the uniques, that is an interesting question. How do you compute? Like, you give you 112. How many unique combinations are there in 112? Well, that's a 3. That's not combinations. It's like a permutation, right? Is 112 and a 112 is the same. So you need to do That's 3 factorial, right? 3 factorial. What's 3 factorial? 3 factorial is 6. Divided by 1 is a duplicate, so it's 2 factorial. So what you're saying is, if we have a thing that have, a1 repeat, a2 number of repeats, a2 number all the way to ak number of repeats, that you say it's going to be a plus 2ak factorial divided by, because you can have all of these, so a1 factorial times a2 factorial times to ak factorial. Is that right? Like if I have 1, 1, 2, 3, 3, how many different combinations unique we have? So 1, 2, 3, 4, 5. So we should say 5 factorial divided by this as 2 factorial times 2 factorial. It's not always divisible, if you realize. Right? That's 1, 2, 3, 4, 5. That's 2 times 2. Well, but this one is divisible, so 30. It's 30. Really? 30. Maybe we'll do 1, 1, 2, 2. It'll be easier. 1, 1, 2, 2. So that's 4 factorial. 1, 2, 3, 4 divided by 2 times 2. That's 4. So we have 6. 6. So we have 1, 1, 2, 2, and 2 can reverse. It doesn't work, right? And then but I guess that is right, because yeah, you multiply by all that, and each one can. Yeah, I think this probably is right. So we just find out how many uniques they have, right? How many uniques in the result they have. Not how many uniques. We want the. I know the full count. I got this. Okay, I just need to count the number of uniques for each one. This can be done. I don't know if Java has this counting, but we can sort that thing. I think surprisingly it is sorted. It is sorted already, so we just need to go from start. We get something, we do the factorial, and then we do another thing, we do a factorial, we do another thing, we do a factorial, and we multiply them together and then do the division. So what I'm saying is to get this one first. No. Oh, God. Okay, so that's like solution 1. And we're going to try a solution 2. That's fine. That's fine. So this is going to be option 1. Right, option 1. Take nums index. So that shall be dp index target minus nums index. Option 2, not take nums index. So when we don't take num index, we just do memo index target plus equal dp index plus 1 target. Right? And then we call dp, and we return dp 0 to the target. Just confirm that we get the same value, 4. Yeah, basically it's this one, this one, this one, and this one. Okay, but now we're going to do something different. We will passing in an array list, integer. Okay, and here we're going to do a list integer array, I don't know, list. And then what we're gonna do is each time when we do this, we'll put it in. So take nums index. Then we're gonna say list dot add nums index. Okay, and then we'll pass list in. Okay, once it's done, list dot pop remove. I guess it's not. Wait, so what is pop? Add, clear, remove, get, remove, sort. I don't see any. Oh. Java array list remove last. Oh my goodness. Seriously. Java 21. Are you using Java 21? I don't see the method. Yeah. That's fine. List dot size -1. Just remove the last one. Okay, so it's linked list, so it doesn't really matter. Right? That doesn't really matter. Wait, hold on. Array list, is that linked list? No, because it's 01 for random access. So anyway, so remove, right? And now we say we'll take this, then list dot add nothing. Then we just do list, not take, so we go to the next one, right? Then we return, perfect. Now it's just here. Don't return 1. All right, so target is equal to this. Basically means we have to, but you know what? I don't quite like this. I think I like to say if this is equal to 0. I think it should still be right. Oof. Something is not right. If target is equal to 0, I shall put it up first. Oh shoot. Yep. So now, but instead of 1, I have a list. Right? I check I can dot out dot print list dot to string. Okay, actually take a look. Yep, exactly. 1, 2, 3. Oh, what happened to the 2, 2? That is interesting. What happened to the other one? And how'd you get a 4 without get a 2, 2? Where is 2, 2? Aww. Seriously, what happened? Can you also print index and target? Oh, we know target. I'm not sure. I don't think you can print that. No. That is not what I had expected. All right, we need to debug this. It's weird, very weird. Let's just put it here. Okay, what do we have? Target is 4. Okay, nothing on the list. Nothing. Yes. Well, take that. So a list has 1. Call it again. Target is 3. I step over. Step into. Step out. Target is 2. Index is 0. List. What's the list? Is 1, 1. That's fine. Step out. Wait, hold on. Step out. So 1. Okay. Okay. Okay, what's this one now? One, 1. Okay, 1, 1. I take 2. That's 1, 1, 2. What's this one? 1, 1. Target. is to index 0 and 2. Oh, index 3, so this is bad. Okay. Index 1, target is 2, dash return 1. Anyway, now we go back to 1, 1, still 1, 1. Two. Yeah, this will do. Index 0, target 3. Okay, so this is index 0, target 4. Okay, this is what we want. There we go. Index 0, target 4. And we have the list is nothing. So go in, target is 4, index is 1, right? So here 1, so now it's 2. The list now have 2, yes. So I take 2 and I go in again. Right, target is 2, index is 1, I jumped out immediately. Why? Because 1, 2 have handled that before. Ooh, 1, 2, I have handled that before. I have handled 1, 2 before. Yep. So I don't go in that anymore. If I don't go in that anymore, I won't be able to collect. Unless I concatenate to array. Huh. Yeah, it will be a bit difficult to do. I see. Unless you can, yeah, that's not gonna happen. I just want a unique way, but I just like cannot even get that. Can't even get that. All I want is just go all the way down, right? So we're starting from 1, go all the way down. Then we're starting from 2, go all the way down. Then we started from 3, go all the way down. How about that? And then when we go all the way down, then we can do the computation. That's an interesting idea. So what I'm saying is we're gonna reset memo every time. So when we get here, I have the list. So what I need to do is to find out the counts. So numerator and the denominator. So int. Oh, that int might not be enough. Maybe it is enough. That's too long. Denominator shall equal to list dot size. Do I have math dot factorial? It does not have factorial. What the hell? Oh no. Okay, there's no, so we have to. Oh god. We need to write one long. Yeah. Otherwise it is then for int I equal to 1, I small equal to x plus plus rest times equal to I. Actually, I'm going to start from 2. And this will just smaller equal to 1. And then return rest. Okay. So that should equal to factorial list of size. And we're gonna do int count equal to 0, and for int count and int pre. That's not int pre. Now int I equal to 1, I smaller than list dot size, I plus plus. Okay, and I should start with 1. If list dot get I is equal to list dot get I minus 1. If that's true, then count plus plus. Ooh, sorry. Right, and then plus plus. Else, if they're not equal, then I can say rest. Then rest divide equal to factorial count. Then we'll reset count equal to 1. And then we'll return rest divided equal to factorial count. Because at the end, when you get out, int. Is that possible? Cost. Yeah, because at the end when it gets out, you have the last one. You will just say if it's equal, so you will have this is 1, right? Then you go to the next one, say these equal, become 2, Go to the next one. Equal become 3 plus 1 gets out, so you have 3, so you have to divide the last one. So yeah, that's basically what I was saying. That's also do memo index. Oh, what if index is outside? So we need to do this plus 1 as well. Now if we do this plus 1, then again, if this target is equal to null, we do all this then we use memo index target. Oh, that's not right. Blah blah blah. So this target shall equal to this thing. We just return memo index target. So that's that. Otherwise, we do everything the same. Does this work? 9. That's not working. That's way too much. Huh. How? 4 factorial, right? I counted 1. I start from 1. If these are equal, so count become 2. Equal, count become 3. Equal, count become 4. And we get out. Then rest is factorial of this, and then we divide by factorial. So that shall be 1. So that should be good. In this case, 3 divided by should be 1, 2, 3, 4. It's actually 5. No, 1, 2, 3, 4, 5. 6 shall be 6. I got 9. Okay, it's okay. We just yeah, sometimes this is easier. Out.print. What do you want to know? I want to know this index. No, I want to know list dot to string, and I want to know so this will help me. That is correct. But why the answer is 9? I don't know. One plus 3, right? Plus 2. Did we plus something again? You are returning. Maybe that's the issue. You are returning 1. You are returning. You know what? If you go this route, I think you need to int res here. Yeah, don't call it res. Total. Right? And instead of, then you're just going through all the possibilities to go to the end. That doesn't, Yep, then you're just traversing. Then there's no memo. Then there's no memo, right? I don't really care. I just keep go until the end. So what I'm saying is, in this case, all I care about is this part. So I'll basically, and this become a void. And I'll simply do this. Whenever it becomes 0, I process it, and then we say total plus equal to res. Of course, I have to go int res, and a return. Otherwise, this will return, and this we basically just, so no any of this. Basically what we do here is we have two options. Option 1, and we just go dp, and option 2, and then here we will go dp this, and I'll return total. Does this work? It's 31. What? I think memo is still needed if I visited from this towards the end. Yeah. Because I want this to be visited only once. So memo is still needed. If target is 0, we handle this, right? And then we say if memo index target is equal to null, which means we haven't handled this one before, then we will handle it. But if we handled it before, then we don't. Oh, we need to, then once we're done, we say memo index. Doesn't matter, we can turn it into a 29. What the hell, man? Seriously, what the hell? No. I'm traversing the whole thing. We add this, then we say this towards the end. Then we add this, then we go this towards the end. And we add this, boom, we have that. Turn, right? Now we try getting this. No, I don't think this is necessary. Can we print something out? Yeah, I'm really confused right now. This doesn't make any sense. Yeah, I guess I don't need this one. Oh, now I have all of them. Huh. Now I have all of them. That is not expected. This to the end. How many unique ways? I guess, yeah, from this towards the end. How many unique ways? I think the problem is with the computation. Okay. 24. Yo. What the hell? 24. Are you kidding me, man? Oh, you forgot to divide. Sorry, I was like, I forgot something. Yeah, this. No, this will be right. 7. So basically, it's a traversal. And then at the end, we just compute. You have another example? 9 and 3. Oh, this will be a very easy case. That doesn't really mean anything. Do we have another test case? I don't know. No, unique. Target, I don't know. 24. Okay, it's a good test case to try. 2, 4, 5, 6, 7, 8, 9. Give me 24. I think this is the right way. So this is not DP. No. This is not DP. This is backtracking. Well, we can actually say int count comp. So give me a list of integers. I return the unique number of that. Then we can do this. Actually, we do this. long count turn int rest divided by factorial count. Okay, then this equal to count combination of list. Option 1, take index. Option 2, don't take. So this is backtracking and count the unique combinations of each possible solution. I don't know the runtime for this. Backtracking. Well, just a unique number of ways we're gonna go through. I don't know. What's the runtime for this? Well, let's try it first. Oh, it's not done yet. Shoot. Oh. By 0. What? Division by 0? The hell? How is it possible? Oh. Oh, that's not gonna fly. That's not gonna fly. They're overflowed. Overflowed. I gotta find a smarter way to compute. Have a total number in its own factorial, right? Then we can find that. Okay, so we find the largest one. Remove that. So it's gonna be this. And the smaller values. Oh, that's gonna be ugly. It's not factorial. Consecutive mode from x to y. Okay. Now we don't do that. We know the total. And we want the counts. Okay. And counts dot add 1. Okay. Then this is gonna be get get. Oh, I have to set it. Oh, shoot. So we'll set this with a value, which is this plus 1. Okay. Else then counts add 1. Okay, once we're done, we say counts dot sort. Or we can say arrays dot sort. Can we do counts? Nope. Or list dot sort. None of them works. Comparator dot comparing int. Okay, how do you sort array list? collections.sort. Counts. Okay. Then we'll say long res equal to consecutive mode. It's going to be counts.get counts.size, the last one, plus 1 all the way to list.size. Then for int I equal to 0, I smaller than counts.size minus 1, I plus plus. Res divided equal to factorial consecutive multiply something to something, right? Well, what's the something? Always 1 to counts get I mean, we can actually say int c. No, we cannot say that. Counts I. Then we will return int res. Doesn't work. Is that a result? Okay. That might be working. Try it. No. Yeah, I guess that was the only way. I know. Jesus. That was bad. I don't know, what other methods? This is the only one I know. This is the only one I know. Right? Whichever one is going to the start. Yeah, we pick whichever one is the start. And then index is this one. If the start, what's the total number of ways? So we'll pick every one as a start. And then whenever it's a start, we have to pick the next start. So we go through this to pick the next start. So what was the right way for this? All right, what's this? I say, well, I don't know from 0 to target everything, okay? If I want to know from 0 to get to target, okay, so from this towards, so for each one, we'll take it. that is the same as what I have here, but just with slight twist. Yeah, let's cut it back here and then, yeah, this method doesn't work. I thought I was being smart, but I think what it says is I'll return dp 0 to target. Okay, from 0 to the end, and every time, yes, it's from 0 to the end. It is from 0 to the end. So if it's no, we do 0, and each time we're going to say from 0 to the end or 1 to the end. Okay. Then, yes, the target is smaller than 0. Target is equal to 0. And that's too much. Wait, how did I do it last time? Oh, this. Wait, how did I not think about this? Well, include index. How many ways can we do if we include index? Right? Then we say all the ways that include the first one with, all the ways that include the first one can give me the target. And then we do all of them. No, it's from index to the end. It's from index to the end. In this range, right? Index to the end, in this range, that can give me target. So I say if I take the first one, then from this to the end, I start from index. Why would you start from index? I take this and I start from here and try to find how many can do this. I agree. But then how do you get like 3, 1? Because you take a 1, then you get a 3, right? I grant you that. Because when you do 3, yeah, exactly. How does that work? How does this work? Oh shoot! It's minus. What? Hold on. That's completely different. What the hell? Wait, what do you mean here? I will minus every single one. Wait, hold on. I have index, okay? Or contain, no, it's not really contain, it's from index towards the end? That's not from index towards the end. What is this? It's saying I will remove this, or remove the next one, remove the next one, remove the next one. But I hold on to index. What is this? What does this mean? From 0, okay? Index is 0. The entire array, we want to find how many ways, right? And then to do that, we say we want to still hold on to the start, but the first value we can take is going to be, take whatever, each one, okay? Then we say from the start to the end. Yeah, did you notice that? This index never changed. I do helper 0, and this passing in is 0. And this is always 0 because it's index. You gotta be kidding me. Why doesn't it make any sense? Target minus nums I. Yeah, we take 1, right? And we have something remaining. So now the question is, so you're telling me I don't even need this index. I just need the target. From the start to the end, how many different ways to make the target? Dude, this is bonkers. Yes, we always start from 0 towards the end. And this target, well, plus equal to minus I. Yeah, this can use enhanced for. And we just return this. And this is all we need. We'll return target. No way. Holy crap. Holy crap. Well, of course, we don't need to sort. This has nothing to do with any of those. So this is not needed. No, you gotta be That's it. Like, seriously. That's it. No freaking way. Wow, it is the way you think about DP, huh? No. Oh, I didn't get this one. Wow. I did not get this way of DP thinking. Basically, it is a 1D DP. We call DP target to find the total number of combinations to make target using the entire range of nums, right? Now, to get DP target, we can choose to remove any number, right? We can choose to remove any number and call DP target minus num for the next iteration. That's it. Yeah. I want to find how many ways to make a target. So each time I just remove one. Okay, so now I have the remaining. I want to know how many, so I can remove another one, or I remove this. So now you know how many times. Holy crap, that is the way. And this I know, this is O(n) squared. No, O(n) squared. O(n), because that takes O(n), right? And this memo is taken, so n times t. Oh. Did I never really write down how this one is done? Oh, I wasn't able to solve it last time, so at least this time I solve it. Yep, that is the solution. I did solve it this time. Yeah, I think I got it. But you don't need index. Oh. Good solution now. You don't even need it's a 1D DP. Alright, that would be it. Didn't even have time for other things. Alright, I'll see you guys tomorrow. Wow, I didn't expect this one to take that long. Adios.